Hi, in this session, I will explain two procedures. One is for how we can do full loads, and one procedure is for how we can do delta or incremental loads. So first of all, I'll explain what is meant by full load and what is meant by delta or incremental loads. Okay, so in general, in real time, we always do delta or incremental loads. Uh, but in some cases, I have seen where we go for full loads as well. That's why I'm creating, I'll create both the procedures and I'll explain it to you. So before going to that, what is meant by a full load? Suppose I have a source. It can be AWS S3, Azure containers, or GCP. Okay, and this is my Snowflake environment, my Snowflake account, where I have two layers. One is staging or raw layer, and other one is target or dimension layer. Okay, so suppose my source is supplying a full file every day, not an incremental file. So it will supply a full file every day. So how we can ingest this full file into Snowflake? By using copy command. Suppose by using the copy command, I am inserting all the data coming from the full file into a stage table of the staging layer. Okay, so as it is a full file, it contains complete data. So I prefer doing truncate and load. Okay, so I'll truncate the stage table every day and I'll load this file. Okay, from this, as this is full load, so I'll do the same to target table as well. So I will truncate the target table. I'll do the transformations required, like renaming of columns or joining of different tables, whatever I do. After doing all the transformations, I'll load data completely into the, I will truncate this target table and load the full data into this target table. So these types of loads are called full load. That means whenever we get a full file every day, I want to do truncate and load in staging area and target or dimension layer. Okay, so these kind of loads we call as full loads. But in very rare cases we go for full loads because the source cannot supply a full file every day, and it is suppose the file is like with 3 GB or 4 GB. So it is unnecessary, right, to process all the rows again and again every day. So in real time, mostly we go for delta or incremental loads. That means we get a incremental file from the source. Suppose my source, it can be Azure Blob Storage or AWS S3 or GCP. So they are supplying these daily incremental files. That means suppose for first day they are sending 1,000 records. Next day they don't send the same 1,000 records unless until there is a change for the existing record. So they will be supplying the incremental files. So how can we ingest these incremental files into Snowflake staging or raw layer? So by using a copy command, so we can schedule that copy command, or we can create a snow pipe. Okay, so you know, right, if we want to do the continuous ingestion into Snowflake, we can go for snow pipe. Okay, so that is based on the file frequency we receive it from source. Suppose source is supplying files daily once or twice, then no need to create snow pipe, right? We can simply write a copy command and we can schedule this. But suppose my source is supplying files uh, for every 5 minutes or for every 1 hour, so it's better uh, to go for Snowpipe, right? It can ingest the changes, whatever the files coming from the source. It will ingest the data into stage table automatically. Okay, so here we have again two approaches. So either we can truncate and load the stage table, or we can append the new files coming in. Okay, so we have both options. But whenever you choose Snowpipe, so you cannot truncate and load the data. So whenever you create Snowpipe, you have to append the data. And so how can we read the only change records or appended records? So if you create append only stream, okay, so then you can create a stream, append only stream on this stage table, and you can read only the changes coming into this stage table. So if it is a append, but if you are using a copy command, I still prefer just truncate and load that stage table. Okay, and then do the incremental loads. Okay, so don't confuse here. So I prefer, if I'm using a copy command based on the frequency, suppose I'm getting the incremental file daily once. Okay, then I'll go for copy command. I'll truncate and load the stage table, and then I will do incremental load. Okay, I will do apply the transformations, and I will load the data into target table. Okay, suppose my file frequency is for every 1 minute or every 5 minutes or every 10 minutes. Then I prefer creating a snow pipe. And whenever we are going for snow pipe, so we cannot truncate and load the changes, right? Because it will keep loading the data. Okay, so in that case we have to create a uh, uh, we have to append the data. We should not truncate and load, but we should append the data coming from snowpipe. Okay, and if we append the data, so how can I read the changes? That means the new records appended. So if I create a stream on the stage table, append only stream, then the stream will be capturing all the new records inserted. Okay, so I can read the data changes from the stream and load it into the target table. Okay, so hope you understood till this part, right? Now, how to do the delta or incremental load? If it is a full load, simply we can truncate this target table and load complete data from stage table. But if it is a delta load, so um, I have to do a incremental load. So how to do this incremental loads? First of all, what is incremental? Suppose if a new record is coming, okay, I have to insert that new record. If we are receiving a record from the snowpipe, but with the update. So we have already this record in the target table, but we are receiving a updated version of the same record. So in that case, I have to update the existing record. So this how can we achieve this? By using the merge query. So you know, right? So merge query, by using the streams we can write a merge query. So based on the metadata action, right? So we can decide it's a new record or it's a updated record. Based on that, we can write the merge query, and we can insert the new records and update the existing records. So this is called incremental load. Okay, so hope you understood, but there is a condition. So if you want to do the incremental loads, okay, there should be a primary key. There should be a primary key mandatory. Okay, on the target table, you should define a primary key. So it is mandatory. Otherwise, how can you say it's a new record or already existing record? So you have to compare the stage table with the target table based on the based on some key. So mostly that key is a primary key, right? Even though the primary key is not enforced on the Snowflake tables, but we have a flexibility of creating these primary keys. So these primary keys in Snowflake can be used for these delta or incremental loads. Okay, so based on those keys only we can identify a record is the new record or existing record. Okay, so if it is a new record, we'll simply insert it. If we are getting the existing record, an updated version of existing record, then we'll update it. So single merge query can do both of these things. Okay, so hope you understood this. So what is the difference between full load and delta load? So again and again I'm saying, in real time we go for delta or incremental loads. Okay, so nowadays everyone is started using snowpipe, because mostly the data volume is huge every day, or every minute, every second also there are some updates coming to the existing records, or new records are coming, right? So to ingest those changes, so better we go for snowpipe. But if it is a the frequency is like we are receiving files once or twice in a day, then we can go for simply copy command, and we can schedule that copy command. Okay, so now let's see how we can implement this full load and incremental load in Snowflake. Okay, okay, first I will explain the procedure for automating full loads. Okay, so before that we'll see where this full load or delta load procedures are very useful. So if we where this can be automated. Suppose when you have hundreds of transaction tables to be loaded, that means if you are getting hundreds of different files into your external stages, if you want to load them to Snowflake, so you cannot create 100 procedures, right? So suppose you are extracting the data and ingesting into Snowflake raw area or staging area. After that, if you want to load the data into dimension layer or into the target tables, Okay, so you cannot create, if you have 100 tables, you cannot create all 100 procedures, right? So that should be automated. Okay, in that case, this is useful. And when you have to migrate huge number of tables from on-premise to Snowflake cloud. Okay, so if you have hundreds of transaction tables present in your on-premise database, it can be anything like Oracle, Teradata, SQL Server, MySQL. Okay, if you want to migrate all those hundreds or thousands of tables into Snowflake, so first you have to generate the files based out of your on-premise data, uh, export those files to external stages or internal stages, and from there load the data into staging tables. From there again you have to load the data into target tables. So here you cannot create again hundreds or thousands of stored procedures to do this work, right? So if you create only one procedure and you call the same procedure with the different table names, okay? So here you are creating only one procedure but calling for 1,000 tables. So this will be automated. But when this will work, okay? So we have one assumption here. So these two automated procedures, full load one and delta load one, works if the source table DDL and target table DDL is same. Okay, otherwise you cannot implement, because if you want to automate, it should be same, right? Otherwise, if they have different structures, then you have to definitely write all. So suppose if you have 100 tables and your source table DDL and target table DDL is different, then you have to all 100 stored procedures. There is no other way. Okay, so the assumption, and it's a mandatory rule here. So these two automated procedure works if the source table DDL and target table DDL is same. Okay. Okay. So I'll explain the procedure for full load. So before that, we have to create the required database, required schemas, required tables, and load some data into the table, right? So I'm creating a database with the name EMP, and I'm creating three schemas: staging schema to store the stage tables, HR data schema to store the target tables, and procs. So this is the schema where I create all my stored procedures. Okay, and then I'll create a table with the name employees in the staging area. I'll create the same table in the target area, that is HR data schema, with the same name. So these names can be different if you want. Okay, but the structure of the table should be same. Okay, so here I am adding one extra primary key. So for full loads, primary key is not mandatory, but just I am adding a primary key on employee ID. Okay, and then I'll insert the data. I'm inserting 100 plus records into this staging table, employees table. So here I'm not going to use snowpipe or copy command. So because I have explained that many times. So I'm just loading some data into staging table. So here our complete focus is on how to automate the work that we are going to load the data from staging to target table. Okay, not on the snowpipe or extracting the data from external or internal stages. So our complete focus is on this area, stage table to target table, how to automate this load. Okay. Okay, so I'll insert some data into staging area and I'll create the procedure. Okay, that will do the full load from staging to target. Okay, and then I'll call. So if I when I call this procedure, the data will be loaded from the staging table to target table. Okay, so the here for full load the procedure is very simple. Okay, so I'm creating a procedure with this name sp source to target full load, and I'm passing two arguments here, the source table and the target table name. That means extract the data from the source table and load the data into target table. Okay, so here the source table and target table are fully qualified table names. That means it contains database name dot schema name dot table name. Okay, so first of all, as full load is a truncate and load every time, so I am truncating the table first. Truncate identifier of target table. So I have already explained where we can use these identifiers and table literals. So this is a parameter that is coming from the uh, function call or procedure call. So I cannot use directly that parameter here. When you want to use a table name that is parameterized one, then you have to use identifier of or table literal table of you have to use. Okay, so I'm using truncate identifier. That means just I'm truncating the target table and I'm inserting into target table select star from the source table. This is very simple query. Okay, so if your table structure is different, source table and target table structure is different, then this query will not work. That's why I told. So it should be same if you want to automate the process. Okay, so if you don't want to truncate and then load, so you can do it in a single statement. So I just commented some of the thing here. I'll explain that. So this is our procedure. That's it. We don't have anything else. Okay, and if I want to simply, I can write the two statements into a single statement like insert to overwrite. So what insert to overwrite will do? It will truncate the table first and load the data. Okay, insert to overwrite into the target table, select star from source table. Okay, suppose if your source table and target table DDL are different, then you cannot automate this procedure. I already told you. So you have to write a new procedure for each and every table. If you have 100 tables, you have to write 100 procedures for a full load if the source table and target table DDLs are different. Okay, and you have to mention the column names explicitly like shown below. So if the source table and target table DDLs are different, then you have to mention the column names as well here. Suppose insert into the target table and the list of fields and then select the same list of fields, okay, from the source table. Like this you have to write. Okay, I have commented this part just for your knowledge. I am sharing the queries here. Okay, and I'm once the procedure is completed, I'm saying return a message full load completed successfully. Okay, let's see how this works. Okay, first let's create the database schema tables and insert some data, and then take the procedure. Okay, so I'm copying the procedure, so I'm just creating the procedure. So the procedure has been created, and so initially I'm selecting the counts from both staging table and target table. So my target schema is HR data. Okay, so select count of 1 from employees table. So the count is 107. 107 records are there in this table. Okay, so initially there is no data in the HR data target schema, so the count is 0. So when I run this procedure, so the data should be loaded from the staging table to this target table. Okay, so I have triggered the procedure and the procedure has completed successfully. So now let's check the count. So I have all 107 records loaded into the target table. So you can verify the data with this as well. Select star from the employees table, HR data dot employees. Okay, so you can validate the data. Okay, so this is how we can do the full load. Okay, this is very simple. But when it comes to the delta load or incremental load, that is very difficult. At the same time, very important in real time. In almost each and every project you work on data engineering, right, or data ingestion and data transformation. So this procedure will be useful. So that is a bit difficult, but very important in real time. Okay, let's see that.